Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hey everybody, welcome to a brand new episode of the Clear to Send podcast. I am joined with Francois, your co-host, and two special guests in a very interesting location in Palo Alto, UC's favorite hotel and restaurant at the Four Seasons. Welcome, UC. And also, we have Wes here joining us because we're going to talk about RTLS failures and any other topics with RTLS. But how are you guys doing? How are you doing, Francois?
I'm very good. How are you? It's snowing here in Canada, so I feel nice and cozy in my office.
Yeah, it's raining here in the Bay Area, so UC brought a little bit of weather.
Sorry about that.
And it's also cold.
Yeah, it's actually cold here in the Bay Area, right?
Wes brought in the cold from Philly.
So we have the weather converging on us, but we're actually on we hijacked a portion of the second floor of the Four Seasons. So thank you, Four Seasons, for allowing us to move your furniture. We'll put it back.
Yeah, and this was a totally rogue thing too.
But we needed a quiet space because they were playing smooth jazz on the first floor, and we didn't know how that would work with our mood of RTLS. But here we are. We're going to talk about RTLS, which I will admit I don't know much about it, and I haven't deployed any of it. So maybe we can begin by defining what RTLS stands for.
Any intros first? Should we do, do we go with the assumption?
I thought everyone knew who you were, UC. So UC's been on the show multiple times since episode number 9, when we walked from the Marriott to Levi Stadium, holding beers and recording at the same time, and hands, giving each other beers.
Good memories.
Those are wonderful memories. And then soon we made it into the Marriott on the presidential suite. I don't know. Your presidential status. I'm not sure. Wes is a president.
Yes,
level.
Correct. We should start with introducing the president.
Yes. So Wes, you weren't on the show at WLPC Prague, but you were in the room.
Yep.
So why don't you tell everyone who you are?
My name is Wes Purvis, and have the good fortune of working now with UC at Mist, a Juniper company.
How much sarcasm was there in that sentence?
There's none.
It's all honest.
It's awesome to work with you as well, Wes. I was just telling Roel and Francois how much I like you 2 minutes ago.
Too bad we didn't record that part.
True. But what do you do at Mist?
I work on the product management team. So a little bit on the product and training and whatever else needs to be done. Yeah, and
I'm Jussi. Also work at Mist. Been here on the podcast for a few times. Thank you guys for having me all those times, and thank you for having me now. I recently moved to Mist like a couple of months ago, and janitorial duty, so anything from I'm a part of the product management team.
Still a janitor.
Yeah, you can't get rid of the title, right? Part of the product management team, but do all kinds of stuff from marketing to sales to speaking to whatever needs to be done. And my history with location is I moved to Ekahau in 2002 when Ekahau was purely a location tracking company, and I've been deploying RTLS during those early years quite a bit, whereas Wes has been deploying RTLS now in the recent years more.
Oh, nice. Okay. So you guys are well-versed then with, I know UC, you're well-versed with RTLS. You have a good background in it. And like UC fashion, I get a call. UC says, hey, I'm in the Bay Area. You want to record something? And so whenever that happens, I always go, is it going to be at your favorite restaurant? And so
it is your favorite restaurant, man.
And when we say we're at the Four Seasons, we are literally at the Four Seasons. So
we are pictures enclosed in the post as well.
Yeah, we'll include pictures because it's true. But we're not here because of the Four Seasons. We're here to talk to UC and Wes because they have RTLS experience, and they specifically want to talk about failures with RTLS. But first, what is RTLS?
That's a good question.
Jussi, I think that you should answer that.
So RTLS is a FLA, four-letter acronym for real-time location systems or services, depending on who you ask. And essentially, for us wireless guys, it means tracking people, tracking assets, providing services on top of that. And throughout the last 15 years, RTLS has been actually made for a surprisingly long time. In Wi-Fi, like I said, I started deploying in 2002 at EKH, and those were some of the first deployments. And we didn't really know how RTLS works, what kind of accuracy it can provide, how are these projects supposed to be managed, and how should we deploy the whole thing. But over the course of years, RTLS has slightly matured, and we have found use cases where RTLS actually provides good value. And why this is relevant for the Wi-Fi engineers is, as you know, often RTLS is provided by the same folks as, so you as the wireless engineer also often end up being the RTLS guy, and with that also the technologies have merged in a sense, or the solutions have merged. So Wi-Fi based location tracking is probably one of the most common ways of deploying RTLS these days, and also these days virtually all of the enterprise access points include some kind of a Bluetooth solution, because Wi-Fi in the past has been the predominant technology for RTLS. Nowadays it's merging more and more, the technology is merging more and more towards Bluetooth. So
yeah, and I would just add that RTLS, I think, is a older term.
Yeah,
and
I'm an older guy.
Yes, so but it's been around for a very long time, and but kind of the new term is LBS.
Oh, it is.
You may also hear that as well.
LBS, what is that?
Location-based services. So they kind of, if you hear LBS or RTLS, they kind of refer to the same thing.
True.
Okay, so we're talking more about location of devices, location of people, location of assets, and with Wi-Fi, there's a level of planning that's involved, a level of design. Maybe let's touch upon those aspects, or maybe we'll go into that as part of the failures, because you would know more about the failures than I would.
But yeah, it's good that you brought it up. When you deploy a location system, planning and the whole project management is the most important thing, I think. Managing the expectations of the customers, because when you ask okay, we have this location solution, what would you like to use it for? And then the customer says, I need inch level accuracy everywhere in order to find a car in this factory, and you're like, well, isn't the car alone many feet long? So do you really need inches? And then you kind of start the discussion from there, limit down the scope of what is the minimum level of accuracy needed, and B, what is it all that you want to do with the location tracking system? Because there's a temptation, people in general, all of us have a tendency of saying yes and pleasing the customer. So it ends up like a huge mishmash of 10 different use cases at once and maximal accuracy at once, whereas the opposite should be deployed.
Yeah, you start with what you want to achieve.
Yeah.
And then go from there. If you say, location could be cool, you're going to end up in a bad situation.
Absolutely.
You won't meet the expectations of location. And location, because you mentioned Bluetooth, which is in a lot of access points now. Is that primarily what people are using, is Bluetooth, or are they strictly using Wi-Fi as their location-based method?
Cumulatively, and Wes can correct in today's situation, but cumulatively, when I was, deploying Wi-Fi in my previous or location in my previous life, it was Wi-Fi, and then there was some. So Wi-Fi is usually based on signal strength. So you try to figure out the signal strengths and then figure out where the client is, and then that gets you so far, like a few meters of accuracy, and then that was augmented by either exciters or ultrasound or infrared sensors to kind of get that, for example, that room level accuracy close to 100% of the time. So that was back in the day. And I think these days it has been merging more and more towards Bluetooth in a way, so that if we look at, this year's deployments, Bluetooth is probably already the predominant technology. What do you say, Wes?
I think it also goes back to use case.
Yeah.
So Wi-Fi as a technology has the kind of the issue of being something that is the Wi-Fi radio has to decide, am I going to locate you or am I going to serve you client traffic? And in that type of situation, you can only get kind of so much of a refresh rate. And so if you have a use case where maybe 10 second, 5 second, or a lot of times it can be up to 60 seconds between a location calculation. And if you can handle that kind of latency, Wi-Fi is pretty easy to deploy. There's considerations obviously for your Wi-Fi deployment, but Bluetooth location or BLE location is a separate radio, and so we're seeing customers kind of move towards Bluetooth just because it's generally easier. It's a little more forgiving with the client serving versus location timing, and so the refresh rate you can have refresh location calculations every second, a couple times a second, and so it enables a lot more use cases.
Yeah,
also,
absolutely.
Well, I just wanted to add something here is what we see more and more on the Wi-Fi side of things as well is the MAC randomization of the randomization of the MAC address when you're not connected, so it becomes hard to track non-connected devices. And Bluetooth also with Bluetooth, if you want even better accuracy, you can use an application, and when you have the user use the application, you also have more engagement from the actual user, so you can start talking about use cases where they can engage with their location a little bit more and provide more value on top of just location.
Yeah, that's a good point, because that's something maybe a lot of people won't even consider, is that randomization, right? And the whole privacy thing. And I don't know if that falls into some of the failures there, but maybe do you want to say anything before you go into the first failure that you want to bring up?
Actually, a couple of things come to mind. Just to for those that don't know RTLS too much, there's two primary vehicles to track here. There's the end user devices, which could be just a simple IT problem. Would be find my lost laptop, or then there could be providing navigation, indoor navigation on your phone. Those applications often are on top of Bluetooth location tracking. But then there's also what's called LBS or RTLS tags. So for tracking people, you could put a wristband on them. You could have a ID card that's BLE enabled, that kind of stuff. And with that comes for example, battery life is a big concern for the tags and also for the applications, but BLE in terms of battery life is also pretty good. You can make the tags smaller, you can make them last longer, and I think that's what we were talking about, where the industry is shifting. That's one of the reasons BLE has become more and more prevalent, because the battery life is always a constraint. Just like accuracy in location tracking is super important, so is the battery life. The other thing is on the whole MAC randomization of Wi-Fi, since we are in the Clear to Send podcast, I think at least before it has been the case that if you send an RTS packet, you can actually hack the MAC randomization by sending an RTS packet, and every chipset in the market, at least before, actually responded that with a CTS packet with the real MAC address, even if they were not connected. Do you guys know if that's still the case? Because that's the way every device could be fooled in the first.
I'm not sure if that's still the case. I mean, I definitely have to test it out and confirm. I don't know, Francois, would you be able to say that that's confirmed?
No, I don't know either.
I would say on the MAC randomization, it certainly can be a problem for location services, but it goes back to what you're trying to do. If you're trying to provide a real-time location of a client, a lot of times it doesn't matter because that MAC address is typically not going to change during that session. If you're trying to do analytics, on the other hand, it could be a problem, and certainly the location system needs to take the MAC randomization into consideration.
Yep.
Yeah, and then I've seen with the new Android version, I think it's version 11, I want to say. But I've seen on the Google phone, the Pixel phone, it randomized the MAC address by default. And even if you want to do packet capture, just normal Wi-Fi analysis, you struggle.
Yes.
Yeah, and Apple has been doing that for the longest time already in an iOS. So yeah.
So if you want to track, like if you want to use location-based services in a public venue and you want to track the flow of people, and you want to track even the devices that are not connected to the Wi-Fi, that's when I think it becomes a problem, because you're gonna be blind on these guys.
And I think even some of the newer devices, like you're talking about, the newer Android and I think newer Windows as well, they do a little bit more advanced scrambling of their MAC address. It used to be
it was pattern before.
It used to be like, hey, just when I'm probing, I'm going to use a random, and when I actually connect to the network, I'm going to use my own MAC address. But now times, especially with the newer Android, it's like when I connect, I'm still going to use that random MAC address.
But at least then that stays static. The random MAC address stays static, right? So
for a little while.
Oh, really? So it's not even within a session, or
no, within a session.
Yeah. Got it. So even if you roam between the APs, of course, it will stay the same. But then if it's idle for reconnects after a day or something,
it could.
Yeah. That's actually interesting. I was not aware of that. Okay, that's good. So going to the fails, I think the first, and this goes back to just a little bit of background while we're talking about fails. Also, shameless plug is most of the many of the listeners probably are going to Wireless LAN Professionals Conference. I hope it's not sold out already it always sells out. I hope it's not sold out by the time this is out. At the Wireless LAN Professionals Conference, I will be having a speaker slot called 10 epic fails of location tracking, and that's why I started thinking like, okay, what are those things? And the first thing that really came to mind is this never say no thing that we already briefly discussed. So people have a tendency to say yes to everything and to just please the customer as much as possible. But I've seen it's the most successful salesmen, as well as, of course, the engineers. But mostly this is, sorry to say, a salesman problem. The more you can say no to customers, the more successful I think you are in RTLS sales, which is counterintuitive.
Yeah, that's counter to selling RTLS. So could you expand a little bit as to, with RTLS, like why that's, say, the failure? Like how does that play for the listeners here who are maybe mostly, I believe they're all mostly engineers. There's a few salespeople who listen, but how would that translate for the engineers?
So for the engineers, this is like, don't say yes to everything, and it is often the engineer's responsibility to try to jump into the RTLS deployment project as quickly as possible in order to start, limiting down the scope, bringing in the technical knowledge, bringing in the right real world experience about the, location tracking, what's possible, what's not, and then kind of steerhead the project towards the right direction. And that means saying no a lot.
Yeah.
And for the salespeople, it's just about let's say you get 10 RTLS leads per day, you get 10 potential customers per day. You need to be able to say no to 9 of them and say no to the right projects and say yes to the right projects.
Basically the ones that will benefit from RTLS, not the ones who, RTLS sounds kind of cool. Maybe we have a use for it. I'd like to try it out. That might not be a successful project if they don't know what they're actually using RTLS for. Absolutely.
And it's not just like, it's the use case and then it's the technology constraints, battery life and accuracy being absolutely the most critical ones that you need to all the time balance.
Got it.
What do you think, Wes? What's your favorite fail?
I think it's the concept. Oh, I just need to deploy my location system, and I'm done. You know? But that's not the way it goes, unfortunately. If you deploy a Wi-Fi based location or Bluetooth based location for whatever use case you're trying to achieve. So let's say it's indoor wayfinding. You're trying to navigate from one part of the Four Seasons here to the restaurant. And
good use case.
So it's not just as simple as deploying that access point or whatever is doing the location. You also need the app. And so that's where a lot of I think customers fail. They don't involve, if it's IT kind of driving this, they don't involve, the marketing team and the rest of the business that can help with the other pieces of the puzzle that you need to make this a success. And that's probably the number one thing I see is just not involving everybody that you need from the get-go.
Right, because that could be a surprise if you think that deploying an access point to give you the location-based services and then assuming maybe with that access point there's a app that you can just turn on, which there probably isn't, you might find yourself having to spend money you didn't account for in a developer to build this application, and even one that fits the brand of the company or the way that the app should feel as again as part of the brand of the company as you're going through the wayfinding, for example.
Yeah, exactly. If it's going to be one of your customers who's actually consuming the location experience, how do they consume it? If it's an app, well, then you want that to have your branding. You want to integrate with your, maybe your existing app that you already have, and I see that just often gets overlooked.
Got it. Yeah, that's a good one.
And you mentioned saving on the application development cost, or somebody has to pay for the location application, and that's one of the fails is trying to save money where you're not supposed to save money.
Right.
And a couple of things come to mind. The software development cost is one. So often this requires qualified developers to create integration or modify an existing application. Like we provide, for example code. We provide example applications at Mist, but often the customer should take that and kind of tweak it to their liking and stuff like that.
I think a lot of times it comes down to the demarcations of the departments in the company.
Yeah.
Right. So if it's IT is responsible for the IT infrastructure, and so that they're going to buy the APs or whatever's doing the location, and then the marketing team or the business is responsible for the app, and so IT says, I provided the location piece, and then it's a different budget that has to build that app, and that's a lot of times where the disconnect comes in.
Absolutely. Which brings us to infrastructure cost as well. So previously it was the case in some scenarios when we did Wi-Fi tracking and had high accuracy requirements that we had to almost flood the network with Wi-Fi access points, which led to two obvious things. Inflated costs, and CCR, extreme amounts of co-channel interference, especially on the 2.4 gigahertz band. And how is it today with mostly Bluetooth-enabled cases that you've seen? Kind of how you would deploy Wi-Fi versus how do you deploy Bluetooth on top of that?
I've seen Wi-Fi location need anywhere from 30 to 50, or I should say, kind of double the number of APs that you would typically need for a bare Wi-Fi. In the Bluetooth world, it varies on the use case. Like wayfinding, you can really get away with wherever you're deploying Wi-Fi. You could put an AP for that has Bluetooth for at least in the Mist world. Other companies you may need to augment with tags, and so
beacons.
Yeah, beacons. Sorry, with beacons, and so for some other use cases you may need to put in more access points like you would for Wi-Fi. It just depends what you're trying to do.
Right, yeah. It all comes with the design of it, right? And so you have different options. You have the Bluetooth built into the AP. You've got these beacons that you could that are battery operated, install them in different places, but then that introduces some other admin
Yep.
to that, right? And then who knows if you remember where that beacon was.
Yeah, and there's battery life has been a constant challenge with the BLE beacons.
Right. I mean, there's jobs created for
Yes,
this to
absolutely.
replace batteries. Once you're done replacing batteries
You
of these
start
units,
over.
it's time to go do it again, either in the same facility or at another facility. But like you said, it just depends on the requirements, right? For Bluetooth, whether you need to install X amount of Bluetooth enabled APs or the beacons, just depending on where that wayfinding is going to go or how you're going to track your assets. That's where you're going to need to have some sort of Bluetooth-enabled device.
Yeah, some enhanced accuracy, and that's one of the things. Like, so for those who don't know, Mist, the where we work, we make Wi-Fi infrastructure. That's kind of pretty heavily focused in location as well. But how Mist was formed, so a few leaders from Cisco left, including Cisco CTO Bob Friday, and Bob, the location has always been a baby for Bob, and he looked at the infrastructure and he saw the same thing, like the beacons, the management of beacons and the battery life of the beacons seemed to be less than a year often and stuff like that. So how he looked at that is put that beacon infrastructure as part of the AP and put in an array. So the Mist APs have a 16 antenna Bluetooth array, which creates more signals and more accuracy from the infrastructure side alone.
And I believe, Francois, you saw a glimpse of this at Mobility Field Day 4. Is that correct?
Yes, they showed us the AP was like a clear cover, so you could see the inside. And I think Wes had some images on his slide. One question I wanted to ask is, like, how many APs would you need to start doing location with the Mist AP, knowing that you have this array of Bluetooth antenna? Is one enough, or do you need like 2, 3? When could you start to do location? Do you need to place them in specific location? We usually say that, in order to do location, you have to place the first series of access points at the perimeter of the area we want to start to do location in. Is that the case with the Mist design as well, or it doesn't really matter in that case?
So it does matter. It certainly matters. And so you'll find that sometimes you'll do a location design, and that your location design may not match up with your Wi-Fi design. Sometimes it does. Like one of the biggest incompatibilities, I'll say, is for wayfinding. We like the AP to be in the hallways, because that's where people
are walking.
Yes, but for Wi-Fi, that's not always the best.
Right.
So sometimes we have a Bluetooth only device that you can augment in. Francois, to your question around the perimeter, that's also true. Particularly, imagine drawing a rubber band around the outermost APs, and the location will work best inside that rubber band. So sometimes, many times a perimeter type deployment is the best place to start. And then third question around, can you do location with one AP? You can, and I've seen it actually work fairly well. We wouldn't, recommend, you're not going to get the really low level accuracy.
What he's saying is don't do it to evaluate the system.
Yeah,
Test it out
it comes down to, it's like,
if you want to
I'm
try
here
it out
and
in
I'm
your
probably
lab.
in this half of the store. Like that's the...
Don't try it even in your lab with one AP. I think you'll look at the results, you'll be disappointed. So put in 4 in a small space and sorry.
I would say 3 to 4. Yeah.
Okay. Because a lot of people will think about triangulation, right? So they're thinking you might need at least 2 minimum to try to at least determine where this device is. But I guess the question with Mist is, you've got this array. Does that improve the angle of where it determines a user is and the distance, for example? Because if you have 2 APs with the array, you can get pretty accurate of where that device is, right? Or even more accurate with another array somewhere in the facility.
Absolutely, and given that it has 16 antennas, 8 receiving, 8 transmitting. So let's say it has 8 for a given purpose. So the challenge is in RTLS is the accuracy, and that's what assists here is not just the angle, but the number of signals. For example, when you're doing wayfinding, the number of unique signals you get instead of 1 per AP, you get 8 per AP. And then you throw in some machine learning AI magic in there, and that also means that the MIST system is not calibrated. Wi-Fi RTLS is for high accuracy. You need a calibration. Everybody knows what calibration is.
Probably not on the listeners of this show if they haven't dealt with location-based services. They might not even have known you needed to do any kind of calibration.
So with Wi-Fi tracking, not so much for BLE, but for Wi-Fi tracking, many systems require a calibration, which essentially means walking around the entire, let's say, hospital, visiting every room quite extensively, collecting measurements, clicking your location on the map. It's kind of like a site survey, but a more thorough one and a more RTLS-focused one. So you slap in like 5 RTLS tags on you, on a belt or a shoulder strap, and then you walk around using a site survey-ish software, but it's not an actual site survey software. Is that fair to say?
Yeah.
Would that tie into Ekahau at all, or any of the validation software?
The ruins of well, because Ekahau used to do location tracking, right. But by Ekahau you mean Wi-Fi design tool Ekahau.
Yeah, any sort of validation tool. Would you be able to validate your RTLS design that way? Because some people might have some questions around that, because they'll probably be able to sense that they could see the Bluetooth icon of the AP.
Absolutely. So this was one of my last baby projects at Ekahau, was the Bluetooth integration. So yes, you can design, you can do an offsite design of a location tracking network using Ekahau, involving AP integrated BLE, as well as we support, or Ekahau supports placement of both beacons as well as the MIST BT11 Bluetooth arrays on the map. So you can, long story short is, in Ekahau you can do the design, offsite design of the thing, but you cannot validate, at least in the current version of Ekahau, which is like 10.1 or something, you cannot validate the Bluetooth deployment. And in general, if we go to validation of the deployment, there's 2 things. There's what's called the statistical validation, which would be like, what kind of accuracy am I getting and where? And that could be things like error lines from the walking path, or that could be heat maps. And then there's
you may still want to do that.
Yes, if you have the tools at hand, absolutely do the statistical validation, but at least do the other kind of validation, which is live using the actual application you're tracking, right?
You definitely want to validate in some way.
Yeah. It's kind of like you always validate a voice quality network using a VoIP phone.
Right.
You also want to validate an RTLS network tracking the actual device in question on both Blue Dot and then using the actual application. If it has like location-based triggers and things like that, you want to make sure that they work.
Okay.
So
what other failures? Go ahead, Francois.
No, I was having a question that came up to my mind. Let's say you're doing the validation and you notice something is off. You notice the blue dot is not exactly where it's supposed to be. What would be the steps you have to do in order to find out what's wrong or fix the issue? Is it because the AP is not installed properly? Is it what would be like your checklist of things to double check to make sure that you configured everything properly?
That's a really, really good question. Just for Wes's benefit, he lost audio on his phone. The question was, and you can take this or I can, so Francois was asking if the dot is off significantly on the map. What is the checklist? What are the things you should do in order to? What's the troubleshooting process for this, and what are the things to check?
I would say, just like with Wi-Fi, I think a lot of times that you start at the lowest level, physical layer, and move up from there. And in location, it's very much the same. Is the AP placed on the map correctly? Is the map scaled correctly? Is the orientation of the AP correct? You start with the simple things and then you work your way up.
Absolutely. And do you have enough coverage? Also, layer one thing. Like, do you have coverage? And also, RTLS likes overlap. So the more overlap you have, the better. And each vendor of these location systems and most Wi-Fi vendors also have pretty good tools for analyzing this.
And going along the fails theme is the physical environment. It's the physical environment can make a huge difference. So the two most challenging environments that we typically see issues in, one is, is there a lot of like metal reflectivity in the area? And the second most challenging, actually it might even be more challenging, is a big open atrium, a multi-floor atrium. So if you have, APs at the edge of this atrium, and they can all hear each other. You can hear, on the floor, you can hear on the ground level, you can hear all the different floor levels. That can be challenging. And that could require some manual tweaking. But so just understanding what does the environment look like can also make a big difference when you're troubleshooting.
And speaking of environment, like high ceilings, like if you have incredibly high ceilings, like 60 feet, 50 feet, 40 feet, that causes challenges to almost any type of location solution.
Because is there a requirement of like how high those APs should be? Is there a threshold that people should know about?
There's no threshold per se. We like to see under 15 feet. We do have a customer successfully using location at about 30 to 35 feet. Okay. But
that's the max. Right?
Lower the better.
And how does that affect the use of directional antennas? Because the antennas themselves they probably don't have Bluetooth capability on them. If somebody wanted to use directional antennas, do they still have the capability of using an array on the AP as well?
That's. I was just on a call today with a large manufacturer in the automotive space, and we'll do exactly that. So first of all, wherever possible, we will bring the APs down, which didn't seem to be a problem. And in many places, they already are for the sake of good Wi-Fi connectivity. But in places where they're not, we will use external antennas for Wi-Fi, and we will still use the integrated radios for Bluetooth. The accuracy in those areas will be augmented or assisted by placing the Bluetooth only radios. And if you don't even have any cabling, then we will also augment with BLE beacons. But usually we don't need to go there. But that's a really good question. And there's.
What about placing the AP on the wall? Does that affect the accuracy of the location?
Absolutely, it does, and for us, it's a ceiling placement that really rules in this case, right?
At least horizontal.
Yeah.
If you need a mount on a wall, to use a 90-degree bracket.
Okay.
Yeah.
Yeah, that would be critical, especially with an array built into the AP. That array will see the devices very differently than an AP that was mounted properly.
Absolutely.
I was thinking maybe we can just let the Mist AI system know it's on the wall and they do all the magic.
Francois was saying to you, just to repeat for Wes, just so you guys know, Wes lost his audio, so he can't hear Francois. But for Wes's sake, Francois is saying, let the AI handle the augmentation, the direction of that antenna. Tell Mist that the AP is mounted on the wall and let AI do its magic.
And then the AI will come and physically turn the Bluetooth antennas
the AI will notify the engineer, hey, this needs to be rotated.
Well, actually, our new AP has a accelerometer and tilt meter in it.
Oh, wow.
So it knows if it's somebody just put this face up on their desk for testing, if they put it on the wall. We haven't exposed all those stats yet, but we do have that data.
Okay, so it can expose something to the user saying this AP, if you have specified that this AP is ceiling mounted and all of a sudden it's horizontal for whatever.
Going back to the troubleshooting, this could be an alert of, hey.
Not mounted properly.
Not mounted properly, or as we call the technical term for it is line of sight.
And we all know that there's going to be a lot of environments where people just won't do a validation, right? So having a lot of these tools try to mitigate some of those problems for us, like something like it's not mounted properly would dramatically help people who are remote, right? And they know there's an installation going on, but they can't physically see how that installation has gone. And so being able to determine whether or not that installation at least went, trying to compare it to a plan, a predictive design, then that would be useful for the user.
Absolutely, and we have our processes that the installers are using a Mist installer app, and they place the AP on the map themselves, and they take picture, which is then streamed to the cloud immediately, and that's being seen to mitigate those problems. At least we catch them. If not the accelerometer, if it's an older AP, then we can tell from the picture.
I would say that another fail is that location is inherently more hands-on than Wi-Fi. And Wi-Fi design, a lot of times you can do predictively. You can do it without sight on scene. Sometimes you can't, but most of the time, a lot of times you can. Mm-hmm. And obviously, best practice is you do validation afterwards. With location, we almost always want you to do a validation,
right?
And we'll see corners being cut in terms of, hey, what do I actually like? Do I need to actually spend this effort? And unfortunately, unfortunately you do. There's tools to make it easier. I would say with Mist versus other vendors, but it's just. You really do need to spend a little bit more time with location, and some customers are just not prepared to invest that time.
Because the fact that location has this the real-time part of it and then the accuracy part of it, it's much more critical in these cases, especially if you're using an application that shows you where you are on a map. You don't want that to show. If I'm in the hallway, I don't want the application to say, no, you're actually in, past the window here. You're actually outside for whatever reason, or you're in a different room. And that just doesn't go well in your environment. It doesn't help the user at all, especially if they're trying to find a specific room and it's bringing them to the wrong room because it's inaccurate. But yeah, I can see where maybe there can be improvements for I guess replacing somebody being on site. We have seen some vendors starting to roll out robots, and people are building machines to do this for them. And I'm sure we'll see more of that as the next couple of years, as people try to build something to automate that process. Right? People are trying to get past that.
In our office, we use Roombas.
Yeah, there you go.
We'll put a Bluetooth tag on the Roomba
and track the Roomba. Make sure it covers the whole area. Is there an area where it's not picking up dirt?
Missing this conference room.
What other failures do you guys have in mind here, or have?
One of the things that comes to mind is this may not be a problem anymore in today's networks, but. Well, actually, let me take another one. The 100% accuracy challenge and managing that. So let's say you deploy a system where you rely on 100% accuracy. That every single time you're in this room or at this exit, you need to do something, and it's not 99, but it's 100. It's like life critical or something. That's a tough one for any location system, given that if the location system produces a location estimate every 5 seconds, that's I don't know, a few thousand estimates every day. It's tens of thousands of location estimates every week. So if you want 100% or never be placed wrong, you need to get those tens of thousands of location estimates right every time, and that's a bit tough. So that's one of my one of the things, and
I think that's a good place to end it. I think overall this was a pretty good discussion about RTLS failures, because I think a lot of this is where you really do have a lot more planning, and so there is a lot more room for error in this case. And then you also have another piece to it, which is the application that needs to tie into the infrastructure to show someone the location, right? So there's a lot of moving pieces, a lot of different things to consider. And Jussi, you had one thing to add.
Yeah, I think and this is for us engineers, right? But the big failure engineers can do is not stay in touch with the technologies. Just like I have here, I've been out of the RTLS game for a long time, and now I'm trying to catch up. But learn the dominant use cases for RTLS, which are indoor navigation, asset tracking in healthcare, people tracking in healthcare, those kind of things.
Well, how about this? How are there any scenarios where location is just not going to be possible?
Let's say you start going to that foot level accuracy in factories and warehouses and things like that, then Wi-Fi and Bluetooth location are not possible. But then there's specialized solutions like ultra wide band that can take place. But typically it's like if you need ultra high accuracy in open environments, then consider technologies outside of what you get from an AP box, and then typically it's ultra wide band then. But yeah, for engineers, learn not just the use cases, but the technologies, and you'll be good.
Yeah, set the right expectations for people and understanding why you have RTLS or location-based services and how it's actually going to work in your environment. And you won't hopefully come across a lot of these failures you guys have.
Yeah, and test it at your site. Just enable location at your the site you're managing, not just at your home, but at the place you're administering, and see how it goes.
Yeah. Well, Jussi, Wes, thank you guys for joining me here at your favorite hotel.
He's playing us out with the music. It's like Oscar gala. It's like the Oscars, man.
Francois, thanks for joining us remotely. And hopefully, I think he's still on, but
thank you so much.
I want to thank you guys for coming here.
Thanks so much, guys.
Thanks for flying out from Finland just for this.
Yet again. Yeah, it's okay. I'll expense you for the first class ticket for a while.
Yeah, we'll talk about that. But where can people find more?
More information, just give us a buzz on Twitter. How about that? I'm first name, last name, and you're...
the real Wes Purvis.
The real Wes Purvis, which also President Wes Purvis might work. And if you Google Jussi Wi-Fi, Jussi Wi-Fi, you will find me.
All right, thank you guys.
Thanks so much.
Thank you, Roel, Francois.
Thank you.